So I'll be talking about the high definition stream survey that we did on the Upper Delaware River. Brett and myself are presenting this with Trutta Environmental Solutions. And I'll just jump right in. Thanks especially to the National Fish and Wildlife Foundation. Jeff mentioned this is part of the 3-year Upper Delaware River Joint Fisheries Investigation Plan, and that had Friends of the Upper Delaware River, the Division of Fish and Wildlife of New York, and the Pennsylvania Fish and Boat Commission. It was also with Trout Unlimited and their Embrace a Stream program in the Shahawken chapter, and then the Upper Delaware Scenic and Recreational River with the National Park Service. So a lot of folks, and thanks to all of you. Jeff even mentioned this. Why is this even exist? What is the problem that we're trying to solve? And that's been known for quite a long time here. Here's a paper from filed back in 2002 that we're able to get great satellite imagery, plane imagery, and get big scale GIS maps. That's been around for quite a while, and they get better and better. And we've, for many, many years, almost as long as we've been doing science, have been able to go out and document very specific local conditions. So microhabitat mapping. We go out and put a transect in and identify every pebble on the bottom and count all the fish and measure the water velocity. But how do you translate those extremely detailed points to a giant watershed? And we've had this struggle, this intermediate scale. How do you map things sort of at the 1 to 100 kilometers at a time? How do you collect this data effectively? That's one thing. How do you make it tie into the big picture models? And how do you appropriately extrapolate these traditional samples? And there's an example of those traditional samples. This is very difficult to do over 80 miles in any rational amount of time when you need to stretch tapes across rivers and take measurements. And so how do we sort of change the picture from that approach to somewhere in the middle of that and flying a satellite or an airplane? So the high definition stream survey, what do we collect? Here's actually a picture from Brett back in his graduate school days going down to East Tennessee River. And we have imagery and different sensors shooting out to the side and the front, collecting left and right stream bank, riparian infrastructure, habitat types, various things that you can see as you float down the river. There's a lot of different sonars running and down videos, so we can see the depth and imagery of the bottom, looking at the substrate and other characteristics. We have water quality sampler running the whole time, so we're collecting information on water quality. We do cross-sectional transects where needed, looking at the bathymetric shape of the channel and potentially discharge. On this project we didn't, but in some projects we can stop and take water samples so we can look at eDNA as we move down the river. All of this is integrated with GPS system so that we know the time, location, and elevation every second. So these little dots at every second, all of this information is being collected and sort of synthesized together. How do we collect the data? We collect it a lot of different ways. These are shots, some of these shots are from the Upper Delaware. This is on Shahawken Creek right here. We have backpack systems, excuse me, that allow us to go up the stream in very shallow places. Where the rivers get a little larger, we can run them in kayaks. As they get bigger, we run them on inflatable boats, and that is me on the Upper Delaware River. We have tablet systems that we can use. Those are especially useful as we get into most dry reaches and some of those inaccessible places like that. And then we do drone and autonomous boat work also. An example of what it is. So just jumping straight in, here is the Delaware River. I am in Nashville, Tennessee right now. Brett's in Panama City, Florida, and many of you are spread across the country. This is the Upper Delaware River. This is one of the outputs of our approach in which you get a stream view video that shows the location. There's Hancock, New York, and this is just below the confluence of the east and west branches of the Delaware River. And you can see the bank condition. We can look underwater with side scan sonar, traditional sonar running. And this is a wider river, so just missed them. But you can see the other boat over here going down the far side, so we get sort of a two-pass look at it. It's fast inventory and assessment. As I mentioned, it's very difficult to stop and collect specific information if you're going to cover a lot of areas. So we covered 80 miles, including 80 cross-sectional transects with 2 surveyors, and it was done in 5 days. So the approach is absolutely a fast inventory and assessment to figure out what's going on in the system. And thanks to all our partners. This is another fast inventory and assessment. This one was just completed recently. This is almost completely backpack. So the Upper Delaware was mostly in boats with some backpacking in the creeks. This is the opposite. Here's 250 miles where it was all walked. All of those lines in there were walked by a team, 700 water quality sites, 175 points of interest. So 6 surveyors were able to do this in 23 days. So it is very fast and can give a complete look at the watersheds. Okay, so we get a cool stream view video. This is Brett actually walking up a tributary of the Chattahoochee River in Georgia. And one of the cool things about it is the spatial metadata, where you are, when you're there, all that information is embedded in the video, so that in the modern geographic information systems like ArcGIS or QGIS, you can put the information in and then click on the map, and this is right below a little bridge, and boom, there the bridge shows up, and you can see the conditions, see if any problems are going on in your system. And you can see a stream here that's severely down cutting with high erosion going on. But again, it allows you to see this stuff and use them in sort of modern computer systems. Not only do you get the imagery, but this system is not something like Google Street View. We do collect imagery, don't get me wrong, but the point of this is to get high quality data to make management decisions, and to do that in sort of a modern framework. Here's a stormwater project in a small city in Tennessee, and this would be our GIS database over here, and we're able to see the time and date embedded in the video. It's embedded in your database. We have the location, so we know the location of the video. That's also here. And now the information. What is this red thing talking about? It gives you all the classifications, which we'll go more into, but here's an example of a poor stream bank. It's a vertical cement wall in comparison to a nice natural stream bank. So you're able to actually identify the exact meter where all of these problems are, having a lot of information associated with the video and all of your data all linked together. And it allows us to do summarization. Here is Cleveland, Tennessee, and these are the streams that are dealing with stormwater issues. We can see this sort of 5-line approach where we have the right and left riparian, right and left stream bank, and the stream bed. And you can see green being good, red being bad. As you zoom in, you can see these different conditions. But not only do we look at these continuous variables, any point feature is identified. So we have locations where pipe outfalls, if a bridge is crossing, whether there's trees falling in the water, whether roads are in there, sediment problems, all of that's identified. This continuous information and point features are all integrated together into a prioritized result. And so in this case, they're looking at areas where they may want to improve the stream to decrease stormwater problems, and the red areas would have areas with high potential for uplift, where green areas you wouldn't gain much for doing a project. So all of this information you see comes out in a very useful format to make decisions. When we talk about sort of data management and deliverables, this first part is just a very brief overview. You get the video from all this, which is great because we can look at it. It's all integrated into geo packages, so all of this information that we're talking about comes in and can be easily inserted into GIS programs. And then there's a complete report that allows you to go through and see the, what was done, how it was done, and what the results are. But in addition to the report, we have a map atlas that goes with it. And here are some of the things that come out of a map atlas. This is the Upper Delaware River. Here's sort of break down smaller maps that are in there. So everything we talk about in this presentation is also available in paper format. We can see things like the water depth as you move along through the river, the habitat type, whether it's a riffle run, we'll get into later how we calculate this, but adult brown trout habitat suitability, this is done for every meter of the river. All of these maps are available so that if you're not a computer guru doing geographic information system work, you can also look at this stuff just straight up in paper format or digital PDF format. And I'll also say that all the naming systems, and thanks to Jeff and a bunch of folks up there, we added into the system. So on this, you can see the river miles, we can see access points, bridges, and then all islands, and then all the different pool names, or, you know, here's Early's Flat and Rest Stop Pool, all of the different things, Fireman's Park. These things are all identified. So not only are we looking at it from a 1 meter resolution sort of approach and looking at it in all these colored lines, this stuff is absolutely tied into the location of how sort of people use the river. When we talk about the approach, this high definition stream survey, I want to say that it's been designed not as a fish survey, not as just a water quality survey or something. We look at infrastructure. So we're looking at the conditions of bridges and whether or not there's log jams on them. We're looking at water quantity issues, so channel capacity, in-stream flow models. There's Brett below a large dam in Tennessee, and we do a lot of work below these dams. We look at water quality issues. Here's an outfall dumping crazy foamy water into a stream. We deal with habitat, and we'll talk about trout habitat in this presentation. And so we deal with all those aspects of habitat. We do outreach because a lot of times we need to be able to get this information from a scientific perspective out to the public. And so these nice videos and things are great ways to do that. And then the stream corridor assessment, you know, where are the good places? Where are the bad places? What do you need to do? All of this goes into EPA's integrated planning framework. So this approach, while we'll hear about a couple aspects of it today that were important to the Upper Delaware River, does much, much more than that. And sort of jumping towards the actual surveys, here's two tracks. This is the boats coming down the east branch of the Delaware River, and you can see Hancock right here. And there's the confluence, and it looks like there's continuous lines. We can see some transects put in various places. Here it is a little closer, and it still looks like two boat tracks sort of tracking left and right. But what it really is a recording that's going on every second. So every second we're collecting this information. And as we zoom in, you can really see it. You can also see where we hung up on a shallow bar right here and had to get out, pull the boat over it, and keep moving down. So this is what's going on. We have this information for every second, which is roughly translate to every meter of the river. We collect digital information. So we have depth, elevation, slope, and habitat type. And here's an example. We know the elevation at the top of the water. We know the depth below it, so we also know the bed elevation. You can see deep spots and shallow spots, areas with steeper slope. This information then can all go through an algorithm and output things like habitat types. We know that pools are deeper and slower than riffles, right? So all of this kind of information is used to classify the overall approach as you go down the river, and used for a bunch of other things too, but I just wanted to show that data is coming in that format. We have the data coming in water quality format, and they're attached on either the back or the sides of the boat, you know, using these sort of water quality probes that collect all kinds of information. Over here, this is water quality. The cold water is being released from the two reservoirs, and it warms up as you move downriver. This is very well known. This is why the trout are living up in this area, and why they don't live sort of all year long, sort of downstream of Callicoon. But we can also see the beaver kill coming in here and warming up the lower section of the east branch. But it's not all that perfectly continuous. You can see different little marks and things, changes of temperatures as you walk down. And so we can zoom in on this. And here's, after we came down a run around the thing, both boats tracked over an area that was a warm spot. So depending on the season, depending on the temperature, we may be seeing spring influence into these where groundwater is at different temperature than the surface water that's being released from the dams. So all that big scale spatial information goes down to very high detail also. We see underwater habitat with our side scan sonar and video. Here's an example coming around a corner here. We can see boulders right in here, fine sand with the waves in it, allowing us to look at very detailed imagery of the bottom as we move down river. The down-looking sonar can be used to confirm that. And we can see the boulders. We can also see some plants growing in it. And this isn't from the Upper Delaware, but on some projects where we're doing repeated surveys, here's a little notch in the side of the Coosa River, and it's still there 3 years later. There was an environmental flow, an in-stream flow released here to improve habitat for endangered mollusks, little shellfish, and they're living in the hard substrate. And you can see this is boulder, the very smooth stuff is fine, sand, mud. Well, they returned a lot of water to this area, and over the course of 3 years, you can see how the increased water flow is moving sediment out of the area and changing the habitat suitability for these animals. So we're able to go in very clearly and define that. We also have all this video, and then from that video, we're able to use it to classify what we see on the banks, what we see. All of this stuff is done from a computerized perspective. And that's sort of a generalized approach of what we're doing. One of the major outputs of what we did for the Upper Delaware River was a stream corridor assessment, or a river in this case, but it's an impact assessment and project prioritization approach, looking at the riparian, stream bank, stream bed, and discrete point features. Here's an example of that. This is on the East Branch, just downstream of the reservoir. The dark green is good, the red is very poor, and then the colors sort of go in between it. And okay, you can look, there's a lot of beautiful conditions on the Upper Delaware River. And for those of you who have been on it, that's well known. This is a blue ribbon trout fishery. It's a beautiful area. But what's going on in some of these spots? Like I said, these represent the sort of cross-sectional area of the river. What is this little red spot in here? I don't know. Great, we have a red spot on a map. Well, if you zoom in, we're now looking at that red spot right here. Let's go to the video and see what we have, right? Now, all this was also defined in the GIS system, but this is actually, I'm running the boat right here, coming around the corner with one of my colleagues right in front of us, and it's nice and clear, beautiful river right here, and we're coming around and you can see already some sort of scum line on the surface. What is happening here? And you'll see as the boat goes into it. Again, I'm in Tennessee, you all are all over the world, and you're looking at site impacts right on the Upper Delaware River. You can see this murky water, all kinds of sediment running into the river. The bottom changed to sort of a hard bottom to a soft bottom. For those of you who read sonar, here's your triple reflections on a hard bottom. Soft bottoms don't reflect sonar as much, and that disappears. So you change from a hard bottom to a soft bottom. A lot of other indications of that are in here also, but this shows exactly what is going on. And oops, I will go to the next slide. Here's a zoomed in overhead view of that track, and here was the boat coming around the corner, going up to right there and then back out again. And here's a stone quarry, and likely their sediment detention ponds are full and leaking into the system. Seems like a simple fix to get that cleaned out and document it, but this is an approach where we're talking about the whole system, finding those locations, identifying what they are, and then allowing the actions to improve the system to be accomplished. So that's a very sort of brief way of looking at project or prioritization. And from that, and there's many other things that we could show in here, it's a complete and a consistent assessment, and it's supported with the data and images. We located sites that have issues with runoff, like you just saw, from tributary impacts, bank erosion, infrastructure issues are all identified through the system. And it can be used to document change over time with repeated surveys. And this is sort of an important point in that a lot of management is done, but how can you tell that things are getting better or are things getting worse? And this is an approach that done every 5 or 10 years allows you to get that sort of typical thing done with what you do with aerial imagery right now. So the other half of the project was looking at habitat suitability for trout, right? And where are they now? Where do we protect? Where do we restore to improve our trout habitat? Where do we introduce them? Where might be habitat for the young of the year and things like that. So some of the outputs, we're going to sort of switch over from the main river to the Trout Unlimited supported work that was done on a couple of the tributaries. And here's Equinunk Creek. And we did complete surveys, habitat surveys, as well as fishery surveys in these things. Here's an example of the conditions, as you've been seeing, riparian, stream bank, and stream bed. Here's some of the discrete features along it that may have issues or impacts on the creek. A few more things. We're also identifying all the habitat type through the system. We're also identifying all of the stream bed composition from boulders to cobble down to gravel and sand. So all of that's identified in the system. And what is that used for? Well, there's a lot of prior research on trout looking at their habitat suitability, and we typically look at water depth, velocity, substrate, and cover. And from that, as you've seen, we've collected this systematically out throughout the whole system, and we're able to then use that to come back and determine areas that are good or bad for these different species, life stages, and whether or not they're using spawning habitat. And again, this is available for the whole system, going from green being very good to red being bad. This is for adult brown trout coming down the west branch. And so from a fisherman's perspective, well, it's easy to see where you may want to fish for larger fish, but from an overall total habitat, we can look at these life stages throughout the river in associated with other impacts. If we had a impact going on right here, this is potentially quality adult habitat, and improving that would improve that habitat. So we can tie these things together. Going back to the creeks, we also then were able to take that, and here is adult brown trout, juvenile brown trout, and spawning habitat down through that same section. So we take that same data set and spin it out to the other things, looking at what projects might you want to do to improve these or to protect these. And what does that look like? I mean, here's a gorgeous shot of Shahawken Creek, and this is all documented. What are the problems? Where are the fish? But not only did we get this above water view, we came back through with underwater pole cameras. There's a camera down on here. We can see what's going on in the water. All this is geo-referenced, and we can go through and look at what's going on underwater. Really cool approach. We were going to train Trout Unlimited to do this on the whole system. Unfortunately, COVID didn't allow us to meet face to face. And so we ended up doing all of this sort of ourselves instead of working with a greater team. That was sort of an unfortunate thing with COVID, but it's a very neat thing. What does this look like? We were able to identify all kinds of things. Here's trout, different species through here. We have darters and dace and all kinds of minnows in there, lots of different fish. We know exactly where it is, when it was, what the information is for those. And from that, here's Shahawken Creek, we have the locations of the species observed as well as the suitability to put it right over top. We have the minnow species or incidentals or things like smallmouth bass and darters and other things like that were observed in the system. What does that look like? Here's Shahawken Creek as we're coming up. Forgive me if it might come across a little pixelated to some of you. It's hard to shoot high definition video over the internet, but we can see these beautiful conditions. And what does it look like underwater? We know exactly where we are. Here's a smallmouth bass and a fall fish up in the Shahawken Creek. cool little guy sitting here. You know, there's lights on the camera, so it lights them up, super easy to see them. Here's another spot on Shahawken Creek. We're seeing all kinds of fish in this little side pocket. And as we sort of move through here, we also see a whole bunch of trout back in the back of this. And so we go from largemouth bass to all kinds of suckers, and then a whole bunch of brook trout in here. So it allows us to actually document what's there, and we have the imagery to support it, that this is what was at that location at that time. So from a real sort of quick trout habitat approach, we documented the life stages and spawning habitat for brown and rainbow throughout the system. In the tributaries, we compared that with the visual assessments to the predicted suitability. And it's the high definition fish survey approach, the underwater fish cams, is an easy, low cost approach that's excellent for citizen science. So the intent actually, like I said, for this project, COVID, some huge impacts on it, but was to work with Trout Unlimited to allow them to go through and survey broad areas with this approach, and then we would come back, take that information and assemble it for them and put it back, and we could have gotten potentially much broader areas of Shahawken and Equinox Creeks completed. So that's sort of the habitat side of it. And I want to address one other issue here before I finish up. We talk about traditional surveys and how HDSS is a different approach or an improved approach. We still need to do site samples, but taking, for example, we were looking at trout habitat. When we typically do work, we're going to go out in the field, we're going to have a data sheet of some sort, and we're going to say, okay, this is habitat for brown trout. And we're going to classify it. We're going to say it's deep enough, it has the right characteristics, and we're going to record that as good. And then back at the office, we'll take all those samples and we'll analyze them. Well, with HDSS, we don't do that. We go in the field and we collect data and it's all recorded, but we don't do any classification. We're not saying anything about trout habitat when we're in the field. That's all done afterwards. Why is that important? Because you don't always know what the problems are going to be when you're going in the field. When we got to the Upper Delaware River, Jeff and the friends at the Upper Delaware River and the numerous other folks told us about this issue. This is Japanese knotweed. I didn't know anything about Japanese knotweed. It wasn't on the rivers that I had been working. So what is important about it? It's that if we had only collected information about trout habitat, recorded and classified everything sort of from a perspective of trout habitat, there's no way after the fact we could have dealt with this. Well, because we didn't do the classification in advance, when they asked about it, this was a simple no cost addition to a project. What is Japanese knotweed? Well, here it is. It was all in bloom at the time. Sort of it's a semi-bamboo-like plant growing on the shores of the Upper Delaware and many places around there. But you can see it on both banks, and you can see where it stops quite easily. And then we can go through and classify it. Here's this little dot is where we exactly are, and we can know whether it's on the right or left banks based on that imagery we were just seeing. So all the yellow is places where we saw it. And we can expand that out. Here is the full extent of the river surveys, and you can see the green is area where knotweed is absent, and red is areas where knotweed is present along the shores. And you can zoom in and see those areas exactly. And this is an invasive species, and clearly it's invasive in the area. But because we have it at meter resolution, we can go through and look exactly the extent over the whole area. And that comes down to how many meters of both banks are covered. And it's basically 45% of the banks of the Upper Delaware River are now occupied by this invasive plant. So Again, one of the cool things is we answered a question, but the other neat thing is I didn't know anything about this going in. This was not a project deliverable. This was delivered because it was important, and the system allows additional things to be answered as they come up. It's reviewable and usable for other techniques. With that, I want to try to keep this short. We're at about 35, 40 minutes right now because I'd like to be able to answer some questions. We work with a lot of state, federal, local partners. This is Nashville, Tennessee, and we've surveyed rivers all over the Southeast, all over the place. Work with everyone, like say from federal, state. We work with a lot of consulting companies. We work with a lot of nonprofits, and a lot of work with Trout Unlimited throughout the country. So the beauty is the approach is really not specific to an individual issue. It's very broad to the water management, fisheries management world, and it can be useful and double checked whether or not you're a developer, a consultant, a regulator. Everybody can see the information and see whether or not they agree with the conclusions. We're a 8A certified, so a minority-owned, women-owned business. And we're in the state of Tennessee. We also have office in Panama City. So that's just a little bit of information. And I'm going to close the talk, and I will leave this up here. As I started in the beginning, thank you so much for joining this. We're giving away Solo Stove to the winner. If you take your phones and capture this little QR code thing, it'll jump you right into a little 3-question Kahoot. Or you can use this URL. I'm going to leave it up until I need to move off this to answering a specific question. But the winner will be notified by email, and we'll send this out to you. And you get a entry for attending, for doing the Kahoot, and for asking any questions. So thank you very much, and I'll be happy to answer any questions.
Well,
see, we have other questions over in the side, so I'm going to let Brett do sort of moderation on that, and for folks who want to ask directly.
So I switched. Anybody who put a comment or a question in the comment, I went ahead and transferred it over to the Q&A session. So I don't. If you can't open it up, I'll be happy to read them off to you. But you actually answered quite a few of the questions during the presentation after they asked. But either way, it should be pretty quick to go through some of these questions. Are you able to open it up and see Pat Quigley's first question?
Sure. The question is, are these comprehensive surveys mostly a once and done effort, or is there a longer term monitoring component to observe changes? That is a question to the management community. There are absolute benefits from a one and done survey. Without a doubt, doing the survey one time, as you just saw, a huge amount of information is collected and allows prioritization. It allows just knowing what's going on. We can look at habitat, all kinds of information comes out of it. Repeated surveys are extremely useful because they show the trend, the trajectory of the river. There's issues going on in the Upper Delaware River. While it's a beautiful river, there are some areas of problems. And are they improving? Are they staying the same? Or are they getting worse? Those require repeated surveys to answer those trend or change over time questions. So super useful for single surveys, answers a giant amount, but then in multiple places we've done repeat surveys aimed at addressing that change over time. So great question.
Perfect, Jim. I'll be happy to read the questions. The next one is asking if the Upper Delaware River data is available to the public. I'm not sure if that's going to be a question for you or possibly for Jeff.
Well, I'll answer it first and then I may throw over to Jeff. Our job basically is the data collection, analysis, and sort of the handover of that data back to the people who funded the project, right? So Jeff is one of those in the States. How that is available to the public isn't inherently, it's not our job to be delivering it. We are moving in the direction of putting this online if, say, Jeff or the state wanted to do this, because the capabilities may not be there at some other places. So that is a possibility. We currently hand it back over to the funding agencies, and then they move it however they want out to the public. I'll ask Jeff if he has any thoughts on that or any further comments.
Yeah, so from the, Jim used the term management community. That would be us and Trout Unlimited in this case, in the Upper Delaware study. And, I'm sure many people on this call are familiar with the constraints of, how nonprofits work. And it really often comes down to, is there funding available to do this once or to do it multiple times? And, as I said in the opening comments, we hope we can keep this going. So, that's how, one of the challenges that we have, of course, is raising funds to, keep this work, get Jim out here again. And let's take a look at some of the trends. Yesterday, he and I talked about something that those of you who are anglers on the Upper Delaware River know all about, which is these, Jim used the term deltas that form at the mouths of many of our tributaries. There's a great example, right, Jim? Like if you came back 3 years from now or 6 years from now or 8 years from now, maybe we see some differences, and wouldn't that be useful to know, right? Because that would tell us a lot. And then in terms of availability to the public, we have sent some preliminary stuff out. We have shared this with the Delaware River Basin Commission, who has a lot to do with the management of the Upper Delaware River. We have shared this with the New York State DEC, I mentioned earlier, who are have now completed a 3-year fish study and are now using that study to develop a first ever wild trout management plan for the Upper Delaware River in the reaches that Jim has been to here, the tailwaters area. So, we also have a macro invertebrate study going on with Cornell University that I think have some possibilities to help enhance the value of that. And we're just starting to look at that. But there's a ton to unpack here. I mean, I think in Jim's presentation, how do you, packaging this up and making it practically useful for what we do, that definitely is going to take some effort to fully maximize the utility of what the work that Trutta has done here. But in terms of public availability, absolutely, and people can contact FUDR and we can kind of unveil this thing. Jim has shown us snapshots of it. We can attempt to answer any questions people have, and if people have ideas of how we use it, we're wide open to suggestions.
Perfect. Thank you very much, Jeff. The next question comes from Vicki Broomhead. I actually met her at the Pennsylvania Abandoned Mineland Conference, and she is asking about, can this method be used in a lake or pond, specifically in a coal mine final cut lake? Can you do monitoring in a column, vertical fashion as well?
So that's a great question. Sort of yes and yes, but we're not talking about the exact same system once we're talking about vertical sampling in a lake. And so we can do that type of work, and we have autonomous boats that are much more suitable for work in sort of mine reservoirs where the water quality may be very poor and people don't want to get in it. So that's sort of a completely different application topic and everything, and we'd be happy to talk about that a little briefly. We just are finishing up a mine project down in Alabama. You saw a little briefly about that on the Hurricane Creek, which is the application to abandoned mines and their sort of acid mine drainage to our river system. So it is useful to that, and we do work on reservoirs and lakes and ponds also.
Thank you. Next is Thomas Carroll. He's asking, are we able to differentiate between groundwater input and surface water input? And also, can you make habitat determinations for other species like brook trout? So that'll be easy.
So the first question is yes, but it's we're basically looking at some basic water quality parameters as we move down. So something like water temperature, you can see groundwater, but if we happen to run it when the groundwater is similar to the surface water, there is no difference in signature. When we're up in the very cold tailwater sections, and the groundwater would be warmer than that, or we're in areas where the surface water is warm and the groundwater may be colder, that signature is possible. And we also look at in terms of pH, dissolved oxygen, turbidity, and conductivity. So yes, but it's not perfect. What it probably does is identify areas that you may want to go back and look at that more closely, because those changes could be caused by other things than just groundwater intrusion. The second part of that is, can you do other species than brown trout, or than other species and do brook trout also? We can absolutely do hundreds of species from the survey. The survey has the basic components. The habitat suitability, we do a lot of work on mollusks, muskies. We looking at trout or gobies, darters, little tiny mollusks, and everything in between. We look at suitability for plant species. All of them just need to have some sort of relationship to the environment, meaning they want deeper water or shallower water or colder. Like the measurements that we use, we build a suitability model, and all of those species can be done. So it is not limited to a single species analysis. It's really very broad and can look at different communities.
All right, thank you. Just addressing some of the comments on here. And so next question will be from Thomas John Clark. He's asking about PHGO. If you're able to jump to the slide that has the water quality sensor, you might be able to explain the 5 basic water quality sensors that we have on there, and then also the option to add others to it.
Yeah, and I'm going back. I'm a little bit slow at this. Probably should do it a different way, but right there.
Could be right there.
So this suite is what is used on most every project. So temperature, pH, conductivity, dissolved oxygen, and turbidity. Depending on the project, we can add different sensors into the system, and we are running a much more complex set of parameters for a project in Alabama, where they're looking for some specific signatures coming into the river above a water treatment facility. So these things can be done more specifically for other issues, but we also have to sort of recognize that some of these samples may have to be held in position for longer and things like that. So not all of them are perfect for rapid surveys, but we do a lot of spots where we'll stop in each tributary mouth and do things like that, looking for impacts to these more specific water quality parameters.
And one thing to add is this method is not beholden to any brand or piece of equipment. Like, you know, we run the Eureka Manas right now because that's what we bought. We have 2 of them, but for Hurricane Creek, we use in situ sondes, and like it really doesn't matter which sonde we have on there, but if you have a specific set of parameters that you need documented, we can either rent what we need, or we can work out arrange a purchase of the equipment in order to get whatever water quality information you would need. And it just, I guess every project's been different as far as what issues are kind of being solved, and so we always make sure we address those initial issues right at first, and then you can kind of build from there.
Yeah, absolutely.
And so the next question is the dates of the survey. I believe it was June of 2020.
Yeah, that's pretty good. I could pull back and pull them up exactly. I want to say it was around the 20th, the 20, something to that effect. I know we, as Jeff said, we had fits and starts. We got COVID made us turn around and go back and all kinds of different things. So I could pull up some of the imagery and it'll put the exact dates on them. And we could also get the information to you to look very much more specific at it. But
June of 2020 is good enough. If you need more precise answers, we'd be able to share that information. Next question is from Trout Boy. What data would you have collected at the quarry location on the East Branch that would be helpful in determining potential harm to the river and wildlife, such as phosphate levels, etc.?
Well, I get that's a super question. And sort of when we go back to the beginning and talk about a fast inventory and assessment, we can see problems. That one was highlighted here. There are also a series of other problems. I just don't have the time to go through them all. But we did not inherently come out with a phosphate sensor, because we were not looking for that specific problem, right? So what we're doing is we're going through the whole system, highlighting the issues in which that could then be addressed multiple different ways, looking more specifically. We could look very likely at the amount of fine substrate downstream of that outfall, because that's going to be one of the stone cutting, the fine sort of dust coming off of it is going to be downstream of that section. How far? Is it a big impact? Those are the kind of things. That's the kind of site that probably requires more information. It also probably is already permitted and maybe just up for cleaning out the detention basin. And that's all that was needed to be done. And then this is back under control again. Again, a single shot looking at all of the situations, but it's difficult to know in advance everything that needs to be sampled correctly. So it absolutely identified it, but we don't necessarily have the full suite of things that you would need to identify if this was a actually sort of going in this from a regulatory perspective.
All right, Chris Holmquist asks, are you mapping the habitat suitability for the conditions you conducted the survey, or have you developed hydrologic models to identify how these habitat conditions change under varying flow conditions in the river based on dam operations? And so this is definitely your specialty as far as how in-stream habitat changes.
So yeah, that's a great question. In directly answering your question, this one was based on the conditions we observed. To get to develop this further into a hydrologic model, you really need 2 points, preferably 3 points, at least, of different flows, because that would sort of allow the development of that type of model. Now, we can, given a lot of this information, start moving towards a hydrologic model. But I just want to caution you, the reality of the details of a lot of these models and the information necessary, it's important to collect sort of validation samples at low, medium, and higher flows to get a very specific answer like this. But right now, suitability is based at the flows that we were doing. And we can extrapolate that, but for this project, it was not done.
Thank you. Can you expound on the result of the eDNA grab samples taken?
Yeah, so that's a great one. And I actually kind of almost deleted that part. We did not do eDNA on this project. That was sort of a broad introductory one. For many projects, there's the need for more specific information. We heard the question about whether phosphate was measured. A lot of samples like that require a bottle sample to get very specific water quality, to get eDNA, to get all of these other pieces. So on a number of projects, we're collecting grab samples or water bottle samples as we move through the system to allow things like that also to be done in the overall picture of habitat and stream condition. On this project, we did not do grab samples, so we do not have eDNA.
And just to add on to that, you know, eDNA, I was just at a conference Tuesday, Wednesday, Thursday, and the technology just keeps getting better and better as far as how easy it is to sample that water while you're out in the field, and then how easy it is to get post-processed, whether you're looking for a specific species such as hellbender, or if you just kind of want a broad array of how many species are upstream of your sample. But when we do 20 miles of river in a day, I mean, there could be anywhere from, you know, 2 to 6 major tributaries flowing in there. And if you're trying to find, you know, where's the most obvious habitat where we can continue searching for these T&E species that we might be looking for, we can stop at every single tributary, and get a specific water quality sample of that tributary and start determining, where do we need to focus our efforts to either find that T&E species or, yeah, I mean, the list kind of goes on, but those grab samples definitely allow for some further analysis to be done. So the next question, how credible is your science? Has any federal or state regulatory agencies used or acknowledged any of your work as credible science?
Oh, great question. I'm not even going to, I may jump around just because we work with lots of federal, state organizations. Jump back to the very end here, just to give you an idea. One of the reasons this is very credible is the nature of what we just saw there. You can revisit the answer. We have struggled, and I dealt with major projects where we've sort of modeled whole states worth of information. But you go back to surveys done in 1992, and all you have is a sheet of paper. And you're looking at it wondering, what did they actually see? What were these conditions? Were the banks failing at the time? With this approach, you can go back and actually look at the system. From a legal perspective, we've been involved in numerous contested case hearings where a board or a judge sits and hears both sides information on these water management issues, trying to make a decision. I don't think we've ever lost a case. We're always on the winning side because it's extremely easy for everybody to see what the problems are. You all saw the runoff coming out of the stone quarry. That was happened years ago on a river none of us are on at the moment, except maybe Jeff and a few of his colleagues. You can actually go and see that. And so the judge looking at it, the public looking at it, knows if I show a condition, well, here, we're looking at Japanese knotweed. We're looking at what's on the banks. We're absolutely looking at what's underwater. So if you don't believe what we do, which I'm totally fine, all of this is available to be reanalyzed. That's the beauty, whether you agree or you're looking at something else, or you just want to do verification, it's all there to be done. So this isn't the case where you end up with some statistical plot and data which is no way to be verified. You actually have it and can go back and re-verify or reanalyze this information to get other conclusions out of it. So it's been extremely effective as a high quality science for use in contested case situations.
Hey, Jim, this is Jeff. Could I just put one follow-up question into that? Like, I can see how this will be very useful for us when we're doing the wild trout management plan. And it sounds like you have experience in the courts where it's been helpful. What about in a regulatory process? Let's say the New York State DEC is under a Clean Water Act, water quality standards, is, reviewing their assessments or their use designations. Have you ever had a situation where your work has been relied upon in a way that has either been informed a regulatory action or maybe even been incorporated into a regulatory action? Does that make sense?
Yes, absolutely. And the answer is 100% yes. And we work with sort of the FERC relicensing process, so the Federal Energy Regulatory Commission, and they're dealing with these hydropower dams and the impact of these hydropower dams downstream is under the purview of that. That's the permit system. This data has been used and is being used in that context on numerous locations. The side scan sonar imagery I showed of the Coosa River bypass is down from a large power dam, and they had no in-stream flow. They turned it off completely when they didn't need it, and then it, water flowed when it was needed. The river was not managed for any environmental habitat, species, anything like that. Over time, that became an issue in the area. The regulatory body wanted to know about things like, why are there these big tributary deltas, and how is the sediment moving through the system? Is it being influenced by the dam, or is it tributary impact? what are the impacts of the T&E species, and those we've been able to track over time. And it is very useful for guiding all aspects of sort of decision making and the overall regulatory outcome. So it absolutely works with that. Has been used that in many cases.
Kaylin Hubbard asks, are there plans to analyze the underwater footage to identify non-fish species as well, such as aquatic plants or mussels?
That's a great question. Currently, no, we did a cursory assessment in terms of whether or not there was submerged aquatic vegetation. In the surveys, it can be done much, much more detailed if necessary. I would, in the underwater fish video side of it, we absolutely identified every species that was seen. This is not a great approach for mollusk surveys because most of the mollusks are going to be in the substrate, and you may see a little tiny part of them sticking out, but you would not see that at the speed we're moving down the river. So you can see dead shells and things like that, but it's not really the appropriate sampling for mollusks. There are other ways that would be better to survey that. But what is very useful to this is if you survey mollusks and you note, okay, here's the map. We surveyed here, and there was no mollusks here, and there was tons of them here. We can go back and get the depth, velocity, substrate, all of these characteristics, and then model where else they might be. So from a suitability perspective, we can take those very specific species samples and extrapolate the habitat out through your whole system to allow you to sample high quality habitat and see if they exist all over the place, or then also do restoration projects. So it is not, this is not the end-all survey for every possible question, but it answers a lot of questions very effectively.
Right. Brooke Dennison, more of a comment talking about how Cornell Cooperative Extension has done several studies in the past years to understand eradication methods for Japanese knotweed, that it might be of interest. And yeah, go ahead.
Yeah, I mean, I think the Japanese knotweed question, I know that Friends of the Upper Delaware River has been working with various folks on how to do this. I am not a plant eradication specialist, so we would absolutely have to talk with someone who knows how to do this and begin to look at it. Where this information is helpful is it really shows where they are and the extent of the problem. So, and it shows it what it was. And the question about when was the survey, 9/3/2020 at 10:55 a.m. is exactly when and where we were at this location. So if we come back to this location, or you guys wanted to go out there and see if all this is gone, what happened? Did someone come through here and clear it? Is it naturally disappearing? Is it now covering both banks all the way up both sides? That's what I meant about looking at that change over time. We know exactly this. And the question about regulatory, is anyone in this thing going to disagree with me that Japanese knotweed is at this location at this time? It's very difficult to come up with an argument that that's not true, unless for some, I don't even know how we go about faking this kind of data. So this is something that you'd come back and begin to look at that repeat survey trend over time, and all these other specialties. I can't even remember the question anymore, Brad. We went so far afield from it, but
you're good. No, you elaborated, but more than enough. There's a lot of different studies and different organizations involved with the knotweed, and so yeah, hopefully they can use this data, and like every project or issue, the more data you have, the better. And that kind of plays into the next question from Trout Boy. Can sharing other entities' data be helpful in any way? We're working with Science on the Fly, looking at water quality at 11 locations in the 80 miles of our system that you surveyed. And we're also working on insect life in the same area with Cornell.
Yes, and again, this goes back to a couple things. One, what is the question? And this can help answer questions. Some questions can't be answered from this data set. Other things need different approaches. But something like the macro invertebrate work, if you have defined locations, and even if you're only collecting macro invertebrate and not habitat data, we can begin to look at how those conditions exist in other locations across to allow you to extrapolate your sampling more effectively. So, yes, again, I will say this does not do everything. Obviously, I'm a huge proponent and it does tons and tons of things, helps in many, many different ways, but some questions need other approaches to get them answered. But this is very useful for extrapolation of point sampling. That's a huge way that could help the work.
Next question was, how far downriver did the study cover? I forget the name of that city where we stopped. There's a major bridge. Callicoon?
Downstream to Callicoon.
So that was
77 miles of the main stem and then several miles of the tributaries. So from the two dams down to the confluence and then down from Hancock to Callicoon.
Was there any data collected on didymo or lamprey eels?
No, sir. Now, if you can see them, then we could potentially get that. But I did not see any lampreys in this. And no, we did not go through looking for, so no.
So the didymo, would that be something we could watch the video again without having to go back into the field to populate? I'm trying.
Potentially, yes. And that is a good sort of example of that wasn't a question, therefore that wasn't part of this project. Not that it's not a good question, and there's the potential of revisiting this information and going back now and looking at what it was in 2020 and potentially going out and doing samples in those same locations at a much more limited thing, looking at those to see what changes are occurring. Again, that wasn't done, but there isn't a reason it couldn't be, but we would have to review, we see underwater in this tiny little box, but it could also be full screen, right? We could look at this and you can stop it and you can frame by frame. So if you can identify things visually, you can identify them from this imagery. So that's sort of a yes, it could be, but no, it was not.
Good answer. Tim Brush, he is asking what brand of acoustics are we using and what kilohertz?
Well, we've used a number of different ones. This is Hummingbird for our side scan, and that's, I think it's the 1150 kilohertz, and that's what we typically restricted inside about 100 feet to both sides. We can use all the different ones on it, but that would be what was used on this project.
This is a good question coming up. Joanna asked, could this technology also be applied to lakes and reservoirs? It looks like a lot of the water quality data collected to be used, but could be used to predict or monitor HABs, which is harmful algae blooms.
Yes. Again, now there's a different question. And when you have something like harmful algal blooms, it is a temporal issue also. So yes, we can absolutely survey reservoirs and lakes and ponds. There's actually a pond survey, a little bit of a pond survey done for the National Park Service on this project that I'm not talking about in terms of this one, but we do surveys on large reservoirs and small ponds and everything in between also. And where this type of work is sort of most useful from the harmful algal bloom approach is looking at where nutrients conditions are within your system, because it's going to be a snapshot. So it requires a confluence of temperatures, events, nutrients, and timing to get these blooms. And that isn't captured in one sample. So this could work in concert with a sort of a long-term monitoring program to then begin to see why are we getting these things in certain locations, looking at currents and wind and nutrient input and various other things, and then where could we potentially improve to decrease the potential for those. So this gives you sort of the template of your habitat, and then sort of a long-term monitoring would give you the time component to look at something like the changes in water chemistry over time that might lead to a harmful algal bloom. So it's one piece of that puzzle.
John is asking, were any forever chemicals detected that killed bugs that feed the trout in the Delaware?
Great question, and the answer is they were not sampled for. So I can't answer whether they existed or didn't exist. Sort of those type chemicals are what we were talking about when we talk about bottle samples. We would have to collect water and send them off to a water quality laboratory to do very sophisticated testing to identify these very specific things. We can't get most of those from a water quality sonde. So that's sort of unfortunate. That is the sort of state of the art right now in terms of sampling for those. So no, they were not sampled for, so we can't address the issue.
But that, and moving forward though, if you have a project where you'd want that information collected, whether it's, every quarter mile or every mile on a main stem to try and figure out, relative concentrations within a river, but then you can also sample those tributaries. And so it is possible, but again, it's just all depends on what's the primary focus of this survey. And either way, good answer, Jim. Any thoughts on what might make crayfish disappear from a small lake? Probably a whole bunch of answers for that one.
I could go to some of my colleagues that are incredible experts in crayfish and their things. Well, they're going to be seasonal issues when you're sampling. They're absolutely water quality issues. There could be predator issues. There could be many things going on for a species to disappear from a location. Not everything is habitat driven. It's the habitat is sort of one of the key aspects, the physical habitat, I should say. Then you have water quality and change over time. The animals require high quality water 365 days a year, 24 hours in a day. We're looking at 1 second of time at this location. So it's something that happens over time, and you could have a single event, some kind of poison gets into the water and kills everything off, and then it goes back to good water quality. This is not the way you would see something like that. You can also have the introduction of different species, and they can change the community. So habitat, your sort of quality of your water, and then your community drive those things. And I don't know what it would be without sampling.
Thank you. Eric Lewis says that my interpretation is that the survey highlights specific locations and opportunities for improvement, i.e. water quality and habitat, and focus areas for protection, spawning areas. Will FUDR and TU be using the survey to focus their projects?
Sounds like we're going to swing that one over to Jeff.
Yeah, so good question. And hi, Eric. Yes, we would love to do that. We have not yet been able to do that, but I did have a conversation with Jim yesterday. I asked him some more detailed questions, I think, Jim, on how that might work. First of all, is it possible, and how does it work? And Jim, of course, assured me that it's very possible and has been done in the past. So we have a whole stream restoration program at FUDR where we're partnering up very closely with Trout Unlimited, and that's been kind of rolling out over the last 4 or 5 years with some significant federal funding. And we hope to keep that going year in and year out and to grow that program. So I can see possibilities here for using Jim's work for not just identifying the places we want to do our work, but also prioritizing them in a world of limited funding.
You know what? Thanks, Jeff. That was super helpful. And I'm going to show a few slides here because one of the cool things about this, we're a small company. This Brett here did some of this work for his graduate work at University of Tennessee. What is it now? 10 dozen years ago or something like that. And we've been working on it since. Questions like that drive what we develop. Well, you're seeing what we did several years ago for the Upper Delaware River and for Jeff's group. I'm going to jump to the end of this thing because it answers that question. This survey was for the National Park Service on the Chattahoochee River, 44 miles, 2 people in 3 days. Brett and myself did this one, and we also did a bunch of tributaries. I want to, let me see if I can, I'm just going to jump to this on it. We have now developed multi-scale assessment to answer the question we just heard. We get these questions and then we say, well, how can we better answer them? This is now applicable to the Upper Delaware River. This didn't exist when we did that project. The National Park Service down there has, this is the Chattahoochee River and its tributaries. And if we look at this little colored bar, green is good, red is bad. There's the riparian, stream bank, and stream bed, and overall combined. So we can look at the river versus the tributaries here. This would be the overall park if you looked at every bit of the mileage, and you can see stream bed is a little worse than the riparian zone. Well, what about the difference between the main stem river and the tributaries, with the main stem on the left and the tributaries on the right? All of a sudden, there's big differences between what's going on in their main river and the tributaries. These are big red bars. Okay, well, how about a question of river segments? They manage the river in 10 different segments. Well, we just go through and map their exact segments, and you can look at differences, and the stream bed is wildly different in a couple of the segments. Okay, so now they're starting to look at it in terms of their management units. How about the tributaries? There's 6 different tributaries done for them. There's a huge difference in stream bank and stream bed between different tributaries. So now what do you do, right? It continues down to sites of concern that are now using this overall multi-scale framework and coming down to the sites of concern, identifying them out of that, depending on how they want to manage the river, like whether you want to break it down by units or these different things. And out of that, every single site now gets a very short paper write-up. This is intentionally blurred because I don't want you to read it. It has a site overview. It has a map of the location. It has the site metrics of why it was bad. It shows pictures of why it's bad. It explains the problem, why the problem is, what the likely cause of the problem is, your restoration approach, access issues, and how correctable it is. Because directly, and I heard this yesterday from Jeff, that he was asking for this from me. Well, so does a lot of other clients. We now produce this so that people, instead of having computer systems and videos and GIS and all the stuff that I like, lots of people just want a couple sheets of paper to walk into a meeting, sit around a table and talk to the other people of concern and say, here's our problem areas. Does anybody have any thoughts, ideas, ways to fix them? There it is in a very simple format to go out and get action done. Now, again, we're evolving super fast as a company because these questions are being driven by the clients. It's a great question. It's a great question coming from Jeff. And this is what happens. This is all able to be done to the Upper Delaware data set. All this is lots of hours of computer programming on those overall things to spit this out of the back end. So again, the beauty of having all the data, all the stuff tied together and reviewable allows us to now spin out other outputs such as this. So I pulled over to that one because I think this is one of the issues with the work we did on the Upper Delaware, as it was now going 3.5 years ago. And things have advanced. And this question came up more than once and came up from Jeff's group. And now we are totally capable of applying that to the data set and giving those kind of outputs. So probably wildly more than the question asked as usual, but it's a great question, right on target of the issues. And Jeff's issues are an example of how does he get this out to the broader community? And how do we simplify it down to an action approach?
Next question is from Daniel Zilker. He is asking, what's the usual repeat time, like every X number of years? And also, I'll be able to answer that. It kind of, one, funding will always be a determining factor, because we would love to do a survey every single year on the same body of water, but you don't necessarily need that. And then as far as like FERC relicensing is a perfect example, because we've done the Weiss bypass, the Coosa River bypass below Weiss Dam. We've done that in 2013. We've done it in 2018, 2021, and we're actually gearing up to do it again this year as part of their monitoring requirement for their FERC permit that they received. And so it's all project dependent. And what are you trying to monitor? Are you mandated to do it? So do you have anything to elaborate on that, Jim?
No, I think that, somewhere 3 to 5 years, but I think it doesn't really make any difference in the sense, the more often, the more data, but what is the question? I will take what Brett said, but we've also seen other things. A single pass on a river in Alabama where the Nature Conservancy has done 30 years of restoration projects. And those projects, some of them are 30 years old, some of them are 20, some of them are 10, 5, and so on. They've got all these projects, and a single pass looks at the fate of those projects. Some of the places you can't even tell there was ever riprap and restoration done. They're gorgeous. Other ones have not solved the problem. And so a single pass can go backwards in time if you know what those conditions were in the past. And so places where you have photos and things, historically, you can use this to sort of go backwards in time and make comparisons also. So one survey is not the only way to get a trajectory, or multiple surveys is not the only way to get a trajectory, but you do need multiple samples over time to get there.
And even adding to that, the 250 miles that we surveyed on Hurricane Creek, and similar to the Paint Rock River, there's been all types of reclamation done to old mining land. And by having this baseline condition of how everything looks right now in May of 2023, you can actually start comparing, what types of reclamation methods were more useful in the past, which one had more benefits to water quality, which ones had more benefits to the habitat. And by using this baseline documentation, we're able to see that on a watershed scale. So you can see past practices, you can prioritize future practices. And then when you go back in 5 or 10 years, you have a way to measure with meter resolution, have there been improvements to this watershed since 2023, or has there been degradation from other types of land use? And so the list kind of goes on. Is there's obvious many benefits from that single survey, but the more data, as we've all said, the more data, the better. So that, I think, fully answers that question. The next one is from Joseph Colville. This one's for Jeff Skelding. Will aspects of this information be directly useful for FUDR and the sort of tug of war with the city over water releases on our tailwaters?
Yeah, in the beginning of this presentation, I did mention that. I think that it can be, and we still need to figure out exactly how and how that can work. We talked about how it's useful in, prioritizing our restoration projects. That's pretty clear now for us. But I would like to explore more kind of, the findings of this thing and talk with some people who are on this call. Actually, some of them are on this call who are very familiar with the reservoir management, and see if we can make some connections here. I think one of them, I see Peter Colasar on the call here. When Peter first saw this, he's very, very long time reservoir management activist up here in Upper Delaware River. Super important to the whole management scheme that we operate under now. I think Peter had a comment. Well, doesn't DRBC, Delaware River Basin Commission, have a study or two where this information might be able to enhance that? I think it was a habitat study, Peter, that you mentioned. So there's an example there where, yes, the answer to your question is yes. But I think there might be other ways that this could be helpful too, that we just have yet to unpack. This is some pretty dense stuff, and we need to take a look at it, and honestly could use some help from some others who are familiar with this type of material and with the policy elements of reservoir management.
Deal. Thank you, Jeff. Last question is from Heather Jaxie. Could you tell if the knotweed was affecting the river temp width depth? I imagine it's probably too pervasive, or maybe a multi-year survey might be needed.
That's another great question. I've learned a lot about knotweed since that survey. It's something that I didn't know anything about prior to the Upper Delaware River work, and now I know a lot more. In a single sort of survey, it's hard to assess whether things are getting wider, getting narrower, are worse than they were or better than they were. So we're back to some of these questions about the trajectory of the system. How is it changing over time? What impacts is knotweed actually having? Now, there are folks that are working in very detail on how knotweed impacts the banks of the river, how it disappears in the winter and causes sedimentation, all of these additional problems. That could then be sort of scaled up to the river to look at the magnitude of the problem. That's probably where it would be most useful. As we look at, say, another survey some years in the future, and go back to looking at it, then you start looking at our locations that have consistently had knotweed getting wider, getting narrower, showing degradation of the banks, or these other questions in comparison to places that haven't. So right now, no, I don't think we can answer some of those questions. I do think that is being addressed by a number of other people's work on the problem in that area. And then the blending of the site-specific work, the very detailed work, to the bigger picture is where this would sort of come together. I guess is my answer.
Jim, it seems to, and I know we got to end soon, but this has been a conversation about this project that I've had many, many times with observers. There seems to be a difference here between, I don't know if the word is difference, but in a lot of these questions that you're getting here, to me, what formulates is there's a difference between observation, what you see, and evaluation. So your example with the quarry, for example, what you're doing there is saying, hey, look, right? Look, we can see it, right? But it would take a little bit more to kind of, figure out, okay, is there harm being done there, or where is it coming from, and what's the source of it? Is that accurate to say?
Absolutely. That's why we go back to the beginning, inventory and assessment. It is not, the data can be used to then make modeling and predictions. But in first pass, it is, what is going on? Where is it going on? What is the scale of the problems? What are the issues, and where are they? We have struggled in sort of the water management area and the fisheries area for years and years and years, in that we either have a big GIS model, and everything is affected by development of the land or agriculture or something like that, or we have these very specific samples in 1 square meter, and we have to extrapolate that, and neither of them work really well. We have all this beautiful big scale GIS, but we have these blue lines on the map. And there's really no information associated. What this is doing is providing all of that rich data to those blue lines on the map. And from that, we now have all this rich data on the landscape. And then we have all this rich data on these very specific topics and points throughout the system. It allows it all to be tied together in some sort of integrated overall approach. Is this the answer to everything? No, it is sort of the link between those two areas that we've traditionally done a good job at. The big, large-scale landscape models and the site-specific sampling. But the tying of those two things together has not really been available. This is now available and being applied all over the country at rapid speed to answer this and tie these big scale models to the very detailed things together to get some of these more system function answers out of it. So that's sort of the big answer here, is that this is the missing piece really in what's going on, but this missing piece is only a third of the answer. The big aerial imagery GIS models are critical and awesome. And those site samples in the water looking at specific velocity of trout habitat or the effect of knotweed are absolutely needed too. It's how do we tie all that together and understand the overall system, what's happening, where is it going, and how can we better manage it?
So to follow up, Jim, just real quick on Heather Jacksy's question, she wants to know, like everybody wants to know, what is the effect of knotweed on sediment? You know, what's, I mean, the common thought here is that it's destabilizing and it's causing accelerated sedimentation. But there is some work out there that FUDR has been associated with in the past. It raises a question mark there. There's some uncertainty about that. So if you, how far could you go in answering that question if you were able to come back 3 years from now, 5 years from now, 7 years from now, 12 years from now, with the kind of work that you're doing? Could you, 10 years from now, could you come back and say, hey, we found something about sediment and knotweed?
That's a great question, Jeff. I know we would be able to see an absolute ton. Now, you mentioned the observation and then sort of the valuation and prediction side of this. This is the observation side. We will see what's happening with knotweed. We can look at, was there changes in sediment downstream or associated with it? We could look at river width. We could look at bank stabilization over time and begin to make some conclusions about it's likely this, because we could look at those. But it still requires somebody to go in there and do an actual scientific cause and effect type work. And that is still required. And again, the folks at Cornell and a bunch of other folks that I've heard talk with your all's work, it's really cool what's going on. And that type work is where that actual answer will come from.
Got it. Thank you.
Good deal. I do want to give a special shout out. I see my old advisor, Dr. Paul Ayers, is in this presentation. So I'm very happy to see you joining. I appreciate it. It's definitely come a long way since 2012 when I finished my thesis.
And I'll say that too, with Paul in here, absolutely. Thank you so much. This project is an outgrowth of the University of Tennessee. Dr. Ayers was a longtime professor there, now retired. Excellent work. Met him years ago and super gracious to allow me to work with all the things that he was working on and with his students, and things have grown from there. But absolutely, just super work, super concept, great work at testing out the proof of concept. This was done at the university level. Then it's spun out to sort of the application level is what we've been working on. And now it's through all that and it's just going great guns all over the place. So thanks, Paul, and appreciate all the work you did to start this.
If you wanted to say anything, you're more than welcome to chime in. If you're muted, but not too big of a deal. And we did have one more question came in from John Centaway. How does the quality of water on the lower river around Callicoon compare to the upper sections?
It's that's a good question. I would probably have to go back and look a little bit into the data. I will say it was absolutely warmer. And then you begin to see some changes. Well, water quality is a very interesting and detailed thing. We see water quality change through the day, right? It's going to warm during the course of the day. We see all kinds of changes that are diurnal, from day to night and things like that. So I don't want to extrapolate too far on specifically the water quality without going back and reviewing it to a specific question to a location on the river. All that is in the report. And I just think in general, we did see the expected warming through there. I will also say that the quality of the river and the water was very good all the way down to Callicoon. So that comment, it may be a little bit warm for trout at getting to that thing, but that wasn't poor water quality. It just might not be suitable for trout. The river was very nice as we got down to Callicoon. So that's sort of a bigger picture, looking at it from a national perspective. The Upper Delaware River tailwater area is very beautiful. The work that Jeff and the rest of you have done up there, I applaud you, because we work on many, many places where this is not the case. It is the absolute opposite situation going on. So well done up there. There still are issues, but I also want to say it is very, very nice.
Trout Boy 2 has his hand up. You can go ahead and unmute yourself and ask away, bud. Appreciate it. You're still on mute, just so you know. It still shows that you're on mute. If you look towards this,
can you unmute him, Jeff? I mean,
I can't unmute people that are in the meeting. But at the lower center of your screen, there should be a little microphone icon.
Okay, thanks. I was clicking on the microphone that was on my photograph.
Nice.
Sorry. So I just want to say, being involved with FUDR for a very long time, how important it is to surround yourself with people that are not only doing the work that is crucial to your efforts, but finding people that you really get along with and that are really embraced by the area and all the people that you come in contact with. And you guys have been just so accessible and so spectacular. Your personalities and your enthusiasm has been infectious. And I just think that needs to be said as well. I think that that's part of FUDR's success, has been able to move into a community not as locals, because very few of us are considered locals in our area. But thanks to Jeff and all of his efforts and our board and all of the hand selection of the employees that we have, and then our partnerships with Trout Unlimited and who we work with, has been really crucial to our success. And I think you guys have been a really good fit. And I think this presentation has been indicative of that also. And I just really want to, say thank you so much for not only the work that you do, but how you do it.
Awesome. I appreciate it. Thank you.
Very much.
Thank you.